Chapter 23, Acceptance Testing. Acceptance testing of PACS serves as an evaluation of its performance, identifying deficiencies, and the availability of the system. The acceptance testing is a technical evaluation of the system, and it demonstrates the clinical readiness for patient care. IT also establishes the baseline for a facility's QC program for monitoring the PACS in the future. Acceptance testing is usually done by the radiologist, PACS administrator, biomed engineers, IT representatives, and or radiology techs. We are going to begin this chapter by focusing on the testing of the communication interfaces between information systems and from these systems to the different modalities. RIS is the primary source of patient demographic and exam information, at least in most PACS implementations. It is absolutely essential for the network between RIS and PACS to be robust and secure. A PACS will not work without it. The connection may be made by a DICOM broker. A DICOM broker is connecting software that changes the format of messages between HL7 and in which RIS and HIS need, and DICOM and PACS need as well. The information system vendor must publish an HL7 conformance statement that defines information that can be shared between the systems. The PACS vendor must also publish a statement that defines their data, but remember, this is called a DICOM conformance statement, which we've talked about in a past module. PACS may also connect directly with the health information system, as well as other systems like dictation, transcription, speech recognition, and billing systems. Some facilities use interface engines. These are used to handle the messages between the systems. They can be unidirectional, one way, or bidirectional, two ways. It doesn't matter how many systems communicate with each other, but the overall system throughout, so how long it takes for a patient's exam from the time the order is actually archived, must be tested to ensure the data has not changed. As part of the acceptance testing project, and just to understand the interaction of the information at your facility, you should really think about mapping your PACS configuration and all the systems that touch it prior to beginning the actual acceptance testing. I want you to take a look at figure 23.1 of your book for an example. As far as modality integration goes, DICOM is key. Each modality vendor will have a slightly different approach to how they implement the DICOM standard for their product, but nonetheless, they must all remain DICOM compliant. DICOM connections are made of 3 ports: the IP address, the AE title, which is the application's entity title. The AE title should be unique and meaningful for each device at your facility. This is helpful when you go to track down an error on your system, so you can easily see where the error is occurring. And the third part of a DICOM connection is the port number. The DICOM modality work list queries the modalities work list, which this usually includes patient demographics, so their name, their patient ID, accession number, date of birth, patient sex, the exam that you're doing, and the modality type. It is usually a separate purchase option from the vendor, so they will probably make you pay more for it. A thread test allows the overall system to be evaluated for integrated functionality and throughput. So first, each module in a complex system is tested individually. Sample data are passed from module to make sure they link up correctly. Clinical scenarios are used to evaluate the information and imaging stream from acquisition to display, printing, reporting, and archival. It can be made to specifically follow a site's workflow steps and how the PACS interacts with that workflow. Thread test tests both the system integration and the modality interfaces. PACS components testing consists of a few different areas. The first we will begin to talk about is image storage and archival. The primary purpose of a PACS image archive is to provide a secure place for the images and the information to be stored and accessed. To properly test a PACS image archive, the system storage architecture will need to be established prior to the testing. So you have to know what you have before you can begin the testing. Most PACS image archive systems can be divided into 3 levels of storage. This includes short-term storage, which are recently acquired exams, possibly exams waiting to get read, or exams that were pulled or prefetched that were retrieved for the next level of storage to be reviewed or compared to the most recent exam. Short-term storage exams can be retrieved quickly for image display. Another form is long-term archive. Long-term archive includes all exams that are stored for historical record, so for a long time. They may have slower display speeds than the short-term storage exams. Then there is the DR archive, which is the disaster recovery archive. This is the long-term archive that is maintained separately from the long-term archive, so it is completely different. Workstation functionality is another part of the PACS component testing. It can be set to each user's preference. This depends on the vendor, so different functions can be configured within the user's profile for each user. Image manipulation functions, exam prefetching and auto-routing ability, and default display protocols must be checked, and this is part of the workstation functionality. All right, moving on to another form of PACS component testing, the PACS monitor testing. So the American College of Radiology and the American Association of Physicists in Medicine have recommended a set of standard testings to be completed on display devices used for diagnostic imaging, so for the PACS monitors. Remember from previous lectures, there are 2 types of display monitors being used today, cathode ray and liquid crystals, LCDs. Even the cathode ray displays are being phased out and replaced with LCDs. So the standards we're going to talk about as far as monitor testing goes is only going to apply to LCDs, since cathode ray displays aren't used as much. So there are 2 kinds of LCD monitors that we are going to talk about briefly. There are monitors with internal photometers and monitors without internal photometers. During the acceptance testing, you will need to validate the photometer measurements and the monitor calibration of your monitors. So before the acceptance testing begins, basic information about each workstation should be recorded. This basic information should include the location of the workstation, display manufacturer and model, the pixel matrix of the workstation, the graphics card manufacturer and the model, and the number of monitors on the workstation.